Okay, so here we've got an example to work through using the wave equation. We have to consider an electromagnetic wave which travels at 300,000 kilometers per second. In this case, it's a shortwave radio signal, and it has a frequency of 1 MHz, so 1 megahertz. And we need to find out what is its wavelength. So the first thing we need to do is write down our wave equation. Here. Frequency times lambda, or if you wanted to put it in other terms it's already rearranged, we're actually looking for the wavelength. So if we're wanting to know the wavelength, it's going to be velocity divided by the frequency. The other thing we can do is we can have a look at our formula triangle. That little triangle, and on the top here we're going to have velocity, and down here we'll have frequency, and over here we'll have lambda. So you can see if we cover up the one we want, so we're wanting to know what is the wavelength. If we cover up wavelength, here we have velocity divided by the frequency, which is what we have over here. So a formula triangle is quite handy. Okay, so then we need to put in what we know. So to find our lambda, we need to have our velocity, which has to be in meters per second. So here, this is actually in kilometers, so we need to times that by 1,000. So that value is going to be 300,000 with 3 extra zeros, so we're timesing it by another 1,000, and we're dividing it by frequency. Now frequency needs to be in hertz, okay, is the standard unit for frequency, and here we have megahertz. Now a megahertz is going to be a million times bigger, so it's going to be 1 with 6 zeros, and that's going to be now in meters per second minus 1, and this one's going to be in hertz. Alright, and what happens now is we can just simply divide that out, and if we were to do that we could cancel out all of these zeros, or bang it in your calculator if you need to, or you can do it visually, and we will get a wavelength of 300 over 1, which is 300 meters.